In this video, we're going to look at parallel and perpendicular lines in the coordinate plane. We're going to focus on the relationships that these lines have based off of their slope and their y-intercept. So let's first take a look at parallel lines. So the first thing we should do is define what is a parallel line. So parallel lines are lines that never intersect and they're in the same plane. So if we look, we have a nice example down here in this graph of parallel lines. So again, we want to look at, when we're talking about these lines in the coordinate plane, we want to look at two key features, and those are the slope of those lines and the y-intercept of the lines. So let's take a look here at those two features. So the y-intercept, that's a little easier to see, so let's focus on that first. The y-intercept of this top line is 4, and the y-intercept of this bottom line is 1. So the relationship between these lines is that their y-intercepts have to be different. Now let's look at the slope. So if you recall, to find slope, we have to look at the rise over the run. So what we do is we find 2 points on the line that meet up at nice grid intersections, such as this point here. We can even use the y-intercept here. And we look at, okay, how far do I have to go up and how far do I have to go over to get from our y-intercept to that second point we chose. So if we look, we have to go up 1, 2. We have to go over 1, 2, 3, 4. So our slope here is 2 over 4, or 1/2. The same thing if we look at the line below there, we have to look at the slope, and to find the slope again we find a convenient point such as this one, and the y-intercept, and we count how far up do we have to go to get to that point. 1, 2, how far over? 1, 2, 3, 4. So again, that line has a slope of 2 over 4, which simplifies to 1/2. So you notice that these lines have the same slope. Let's go over here and put that down. So these equations have the same slope. So looking at that, we've determined that parallel lines have to have the same slope and different y-intercepts. All right, let's take a quick look at perpendicular lines. So perpendicular lines, let's define that first. So these are lines that intersect at right angles. And that's what perpendicular means. It's when two things come together to intersect at a 90-degree angle. So in the coordinate plane, when we look at that, we want to again look at the slopes and the y-intercepts. So again, let's look at the y-intercepts first. So this line has a y-intercept right here, which I'm not really sure what that point is, but that's where it's crossing the y-intercept. And it also has a y-intercept here. What's interesting about these perpendicular lines is even though that these two have different y-intercepts, it's actually possible for them to have the same y-intercept. And that's if where their point of intersection is, if that point actually is the y-intercept. That's when they can have the same y-intercept. But more importantly, let's look at the slopes of these two lines. Let's zoom in here. So the slopes of these lines, again, we want to pick convenient points on the graph that cross at a grid. So let's say for the positive sloped line, this one here, let's look at this point and let's do the point of intersection. So the slope of this line would be 1, 2, 3 up and 1, 2 over. So the slope of this line is 3 over 2. Now let's take a look at our second line, our line that has a negative slope. And let's pick some other convenient points here. Why don't we pick this point here and this point here. So again, we want to figure out rise over run. So to go from this top point to this bottom point, I have to go down 2, that's -2, And I have to go right 1, 2, 3. It's a positive 3. So the slope of this line is negative 2 over 3. Let's go over here and compare the slopes. So the first slope had a slope of 3/2, and the second line had a slope of negative 2/3. So if we look at those two slopes, you may notice that really that's just this fraction being flipped, but then also it's changing signs. So what we call that is an opposite. That's the changing signs part. Opposite, changing signs. And when we flip a fraction, that's called a reciprocal. And so that is the flip of a fraction. So in every pair of perpendicular lines, the slopes are what we call opposite reciprocal slopes. So they are flipped and the sign is changed. Okay, so let's recap again. Perpendicular lines. Those lines can have the same or different y-intercepts, and their slopes are opposite reciprocal slopes. All right, let's get some practice with this opposite reciprocal idea before we move any further with this concept. So we want to find the opposite reciprocal of each of these slopes. So let's take a look at the first one. The opposite reciprocal of negative 2/3, which is actually the problem we just did, would be 3/2, because we flipped the fraction and we changed the sign. Alright, next one, 11/12, the opposite reciprocal of that. And notice I'm not putting an equal sign but an arrow, because they're not equal to each other. We're doing something to this fraction. The opposite reciprocal of this would be 12 over 11, and because it started positive, we have to make it negative. Alright, number 3, same thing. This line has a slope of 7, or this is a slope of 7, so what we have to do is the opposite reciprocal of that, so we flip it. So keep in mind that a 7 is really 7 over 1, so when we flip it, it's just going to be 1 over 7. And again, since it started positive, we're going to change that to a negative 1 over 7. And then finally, last one, making negative 1/9 slope the opposite reciprocal, it's going to end up being 9 over 1, or simply 9. And because it was negative, it's going to become positive. Alright, so that's some good practice with opposite reciprocals.